All right, so we are going to be looking at some similarity theorems. In the last video, we saw that we have angle-angle similarity, and that simply means, restating that again, I'm not going to write it out though, that if two angles of one triangle are congruent to two angles of another triangle, the triangles are similar. That I will write here, and just making sure that we understand that these triangles are similar, not congruent. The angles are congruent. So those two angles that I've marked in the red are congruent because that's what the markings mean. From our theorem from the last video, we also know then that the missing angles, or the angles that aren't marked, are also congruent. Those top two there that I just marked in yellow, they have to be congruent as well. And when you have angles that are congruent, that automatically means the triangles, it only works for triangles, automatically means the triangles are similar. It means their sides are proportional. So it does not mean that this side here and this side here are the same. That is not necessarily true. We don't want to even mark it like that, right? It just means that they're proportional. We have two other statements that we can look at as well that will prove that triangles are similar. We're not going to prove these statements. We're just going to go through them and then use them. So the next theorem that we have for similar triangles is side-side-side similarity. Very similar. We've had this theorem before. We had side-side-side before, but we had side-side-side when it came to congruent. Excuse me, if you recall what that said, back when we did this in Integrated 1, we said that if three sides of one triangle are the same, are congruent to three sides of another triangle, then the triangles are completely congruent. That gave us the angles for free. What this says, it's a little bit different. This one we are going to write out. This says, if all three matching sides, and that's important that we have it as matching sides, if all three matching sides of two triangles, not congruent, but are proportional, and I spelled proportional wrong, proportional, there we go. If the sides are proportional, then the triangles are similar. What does that mean? That means that if the sides end up reducing down, the matching sides all reduce down to the same scale factor, then the triangles are similar, and that means that the angles are all going to be equal. The sides won't be. And so how does that look? Well, let's get an example. Poof, like magic, there are our triangles. So these triangles are going to be similar because I set them up that way. We need to set up the proportions. Now, you have to be really careful. The orientation can get all flipped and weird, and just because the way that you originally thought they were oriented, if the proportions don't work out, you have to be careful. It can be really, really difficult to match things up. For example, if you think that, oh, I know the scale factor, I can clearly see that PZ is 6, and QL is 12, so it must double. 6 times 2 is 12, but if you look at any other side, say 15 to 10, that doesn't double. Neither does 15 to 4, and so we might look at it and say, wait, these triangles aren't similar. Well, you have to be careful. You have to make sure that you're looking at any and all different combinations, because side PZ, that side could match up to QL, or it could match up to AL, or it could match up to QA. How do we know? We don't. We have to test them out and play around and see what if these two are the same, if these two are the same, if these two are the same. For this example, I'm going to jump right to what it is. I'm going to write the similarity statement, triangle PZC. I'm going to go in that order. Is going to be not congruent. Let's get rid of that congruent sign. I'm so used to writing congruent. Let's make it similar. Is going to be similar to triangle. Now we have to make sure we match them up correctly, because I wrote the problem. I know how it matches up. It's going to match up to QAL. We can see the scale factor fits this. Remember that with similarity, the sides aren't congruent, but their proportions the ratios are congruent. The proportions work. So PZ matches up with QA based on that statement. That fraction should be the same as PC and QL because those letters match up. And that should be exactly the same as ZC and AL. All of those fractions should reduce down to the same thing. So if we take a look at what those fractions all are, we can clearly see by looking at the picture that PZ is 6 over QA. QA is 4. That's got to be equal to the other sides that match up, PC. PC is 18 over QL. QL is 12. And that's got to be equal to my other sides. Side ZC is 15. Compared to side AL is 10. If we look at all of these three fractions, we can reduce them. We can clearly see that the first fraction we could divide numerator and denominator by 2. The second fraction we could divide numerator and denominator by 6. The third fraction we could divide numerator and denominator by 5. If we do all of those calculations, we end up getting the scale factor, and we can see by dividing any and all of those that our scale factor is 3 over 2. The ratios are all the same, and so that means that the triangles have to be similar. By that similarity, what we get for free, and I'll highlight that in blue, because the triangles are similar, we automatically now know that angle P and angle Q are the same size, angle Z and angle A are the same size, and angle C and angle L have to be the same size, because with similar triangles, the sides are proportional, the angles are equal. So let's take a look at an example of how we can utilize this. Boom. Are these two triangles similar? ABC and DEF could be that order, could be a different order, who knows? But we have to try and see if these triangles are similar. So we have to be, again, very, very careful. We don't know what side could potentially match up with the other side, but there's a quick way to figure that out. If you look at triangle ABC, hopefully this is obvious. The smallest side, side AB, would have to match up with the smallest side over here, FE. The middle side, side BC, which is 4, would have to match up with side DE. And then finally, side AC, which is 5, would have to match up with side FD, which is 7.5, the biggest. So when we have these measurements, it becomes a lot easier to try and match up, because the smallest would have to match up with the smallest and the biggest would have to match up with the biggest. Otherwise, the proportions would never be equal if, for example, side AB 3 matched up with side DF 7.5. There's no way then that the other sides are going to end up being in the same proportion. So all we need to do is check the scale factor for each pair. You have to look at all three. And so I need to look at, in no particular order, I'm going to take a side AB. Now side AB, because it's the smallest, would have to be the smallest side in the other triangle. I don't know if it's going to be FE or EF. It doesn't matter how I write it here. It will matter when I go to write my similarity statement. If these triangles are similar, hint, hint, they probably are. The middle side for triangle ABC is side BC. The middle side for the other triangle is side DE or ED, I don't know. But what I can look at is in my other statement, I matched up B and E. So if I want to make a guess at that, then I'll go ahead, get the right marker. I'll go ahead and put E here and then put D here. And then finally, side AC, our biggest side in triangle ABC, would have to match up with the biggest side. Since A and F are in the same position in the first fraction I wrote, I'm going to keep consistency, and I'm going to go ahead and put the F there and the D there. Now, I don't know if that's true. It could be that AB matches up with EF. But the measurements won't change. The measurements are going to be fine. The order of the letters will fix when and if we need to fix. So, if we look at the measurements, AB, we can clearly see AB is a length of 3. FE is a length of 4.5. If we go to BC, BC has a length of 4. ED has a length of 6. And finally, AC has a length of 5. And FD has a length of 7.5. So, Once we've got that, we need to reduce these. I know they have decimals. Don't freak out. It's okay. We can still reduce them. 3 and 4.5 are both divisible by 1.5. 4 and 6 are both divisible by 2. And 5 and 7.5, if we want fractions, we don't want fractions, do we? No, of course we don't want fractions. Or excuse me, we don't want decimals. So if we don't want decimals, if we divide these both by 2.5, we won't have decimals. And so if we do that and do those calculations, 3 divided by 1.5 is 2, 4.5 divided by 1.5 is 3, 4 divided by 2 is 2, 6 divided by 2 is 3, 5 divided by 2.5 is 2, 7.5 divided by 2.5 is 3, and so, since they all reduce down to the same scale factor, yes, the triangles are similar. That was a weird looking triangle symbol. Let's try that again. The triangles, there they are similar. Now, we didn't look at any angles, and it's okay, we didn't have to look at any angles. We have side similarity because the 3 sides of one triangle reduce down to the same proportion with the 3 sides of the other triangle, and so that guarantees us that they're similar. Not only does it guarantee us that they're similar, it also guarantees us that the angles are going to be equal. Now, which angle matches up with which? Well, if we look at how these triangles are oriented, since the smallest side here and the smallest side is here, if we go to the next biggest side, I'll do that in yellow, it's going to go like this, and then the third biggest side, or just the biggest side, would be this and this. And so if we kind of get that order with the colors, we can clearly see then our similarity statement will be, I'll go ahead and put the first triangle in order, triangle A, B, C, in alphabetical order. And so then if we roll through in the same direction, triangle ABC would be similar to triangle FED. And so that would mean that angle A and angle F are congruent, angle B and angle E are congruent, angle C and angle D are also congruent. So let's take a look at one more theorem, the side angle side similarity theorem. So what the side angle side similarity theorem says, very similar, I'm not going to bother writing this one out. It says that we have 2 sides that are proportional, hence those S's, and then we have an angle that's equal. And so we have to be very, very careful when it comes to similarity. Angles are still equal, sides are proportional. So in this picture would represent side angle side similarity. We can see that this side marked 6, and this side is marked 9. That is not my intention. Let's change this. That shouldn't say an 8 there. Erase, erase, erase. Let's make that a 12, which is what I intended it to be. So we can see that that's one is 6 and then one is 12. In the other triangle, we see that we have, let's do them in different colors. Let's get rid of, nope, we want that 12 to still be a 12. We just don't want the highlights anymore. There we go. So that's 18, that's 12, fixing it, now we're good. And so 6 and 12, we can clearly see that if we multiply 6 times 2, it would equal 12. And then we can also clearly see if we multiply 9 times 2, it would equal 18. So those sides are proportional, and so we have the SS portion of our side angle side similarity. What we're missing is the angle, but we do hopefully clearly see that we have vertical angles, and we know that vertical angles are congruent. That angle right there, that's going to give us the angle portion of side angle side similarity, and so these triangles are definitely similar. Again, that means that the angles all match up and the sides are all proportional. So let's say we figured out for doing some math or whatever that this side was 5. Well, then we would absolutely know that this side would have to be 10 because of the similarity. Okay, side angle side similarity works the same. The proportions have to work out to be the same, all of that stuff. So to give you just a little bit of practice, work on some similarity, page 434. Not a ton of problems here to practice. Problems 16 through 20, work through those. And if you have questions, send me a remind. But there's your triangle similarity, and until next time.